Hello everyone, my name is Prajwal and our team name is Pathfinders. Our project is called AresNav AI, which is an AI-based mass terrain analysis and navigation system. The goal of this project is to help a rover analyze terrain, find safe paths, and make navigation decisions automatically without human control. This is important because communication between Earth and Mars takes time, so the rover must make its own decisions safely. Now I will give a quick demo on how our project really works. So this is our first page. First, we have to upload a trained AI model which is stored as .keras file. This is the .keras file and we are going to upload it now. So here as we can see our .keras file model has been successfully loaded. Now then the next step is to upload. First of all, let me tell you about what this .keras file really is. This file contains the trained neural network which has already learned how to recognize different types of terrain. Our model is based on model net v2, which is used for image classification. Once the model loads successfully, the system is ready to analyze terrain images. Now the second step is to upload mass terrain image. So from here, we are going to upload our image. So here, as you can see, the image is being analyzed. That is, it's analyzing the terrain. So here we can see that the raw telemetry view. This is the image that we have been uploaded. This shows the original terrain image that we have uploaded. This step helps us to confirm that the correct image has been loaded into the system. The next step is the safety heat map. In this view, the system assigns safety values to each terrain patch. Green areas represent safe terrain, while the red areas represent dangerous terrain. This helps the rover understand where it is safe to travel. The next step is terrain classes. So here we set the terrain classes. The AI model classifies each path into terrain types such as bedrocks, rocks, sand, and pebbles. These steps converts the raw image into meaningful terrain information. So our next feature is the safety score and confidence breakdown. As you can see on the right side, we can see the safety score and the confidence breakdown. This shows the overall safety level of the terrain. For example, here the terrain shows moderate risk, that is, the safety score is 41%. And here, as you can see, a description about mixed terrain detected, that is, there is a moderate risk. The rover has been seen. This shows how confident the AI model is about each terrain type prediction. Below that, we can see path projection, stability, warning, and AI info. So in this stability we can see slope, traction, stability, traction, and many more things. And here you can see warning AI info. The AI info gives useful details about terrain safety and environmental condition. And this gives the warning. If the safety system detects risky terrain, it shows a warning message. I won't go too much in detail about the stability. Because I'm just giving a short info. So the next step is run run full terrain analysis button. So after clicking this button, this starts the full navigation process where the system calculates the safest route automatically. As you can see, the optimal global path has been calculated, and here we can see the A star pathfinding algorithm has been successfully loaded. So here we can see this algorithm calculates the safest and most efficient path from the start point to the goal point. The path avoids dangerous areas and prefers safer terrain. So here, as you can see, this is the navigability graph. As you can see here, This shows how easy it is for the rover to move through different areas. Areas with higher values are easier to travel. The next is safety grid. Here, the grid shows safe and unsafe regions in a clear way. Green cells are safe. Green cells are safe while the red cells are dangerous. The grid helps to guide the rover safely. So as you can see, the green is the start goal and starting point, and the red cross is the ending goal. And this is how the rover has calculated its path successfully. The next is the decision grid. In this, the rover uses the grid to decide how to move forward. It checks the terrain ahead before making movement decisions. The next is the smooth path. In this, after finding the path, the system applies path smoothing. This removes sharp turns and creates a smooth and realistic overpath. This makes the movement safer and more natural. The next is decision overlay. This is the It shows how the rover checks the terrain ahead using look ahead points. These points help the rover detect danger before reaching it. And so this is how the rover makes its own decision. So further we move to our final step, that is neural network attention gradient. So here this shows where the AI model is focusing while making predictions. Red and yellow areas shows regions that strongly influence the model's decision. This improves transparency and helps us verify the model is working correctly. So this is how our system totally works. In conclusion, I just want to say that our system combines deep learning, terrain analysis, and intelligent pathfinding to create a safe navigation system for Mars rovers. This project demonstrates how AI can improve autonomous exploration and mission safety in extreme environments. Thank you.